Okay, we talked about the Arrhenius definition of an acid and the Bronsted-Lowry definition of an acid. Like I said, I'm not big on, do you remember the name of what kind of an acid it is? Here's a third definition, though, the Lewis definition. So Arrhenius was talking about ionizing and forming hydrogen ions. Bronsted-Lowry was talking about donating a proton. And here we're thinking of it in terms of transferring electron pairs. So an acid is an electron pair acceptor. A base is an electron pair donor. So here we have ammonia. This nitrogen has a lone pair of electrons, right? When this hydrogen comes over and attaches to the NH3 is donating this lone pair of electrons to the hydrogen. It's like, oh, you poor thing, you don't have any electrons. Here, I've got these two. I'll share both of them with you and we can make a covalent bond together. Isn't nitrogen generous? So the nitrogen is donating electrons. That makes it a base. The acid is accepting the electrons. The donating has to be opposite of the protons. Any questions yet? The Lewis acid definition is important because it expands the definition of what can be considered an acid. Lewis acids do not have to have hydrogen in them. We don't have to have an aqueous solution even for things to be acidic or basic. So this is really important in OCHEM. So Lewis acid doesn't have to have hydrogen. So here we have ammonia, which we've recognized as a base before. And here we have BF3. So BF3 is one of those guys that has an incomplete octet. It only has the 6 electrons shared with the fluorines, and it's got an empty space, an empty orbital. So this can come and attach to the Lewis base. This is called a coordinate covalent bond, where nitrogen's very generous and donates both electrons for the bond. Nitrogen has donated electrons, it is acting as a base. BF3 is accepting electrons, it's acting as the acid. So this is a Lewis acid, that's a Lewis base. This is called an adduct. So the Lewis acid will have an empty orbital, or it can rearrange its electrons to make an empty orbital that can accept an electron pair from the base. So like that BF3, molecules with incomplete octets can act as Lewis acids. So here we have aluminum trichloride. Aluminum has an incomplete octet here, so it can form an adduct with ammonia. So this is the Lewis acid, that's the Lewis base. Here, boron, trichloride, empty orbital here. It's deficient, it only has 6 electrons instead of 8. Well, this guy, diethyl ether, this oxygen has 2 lone pairs. And so this can donate a pair of electrons to the boron. So this is the base, and that's the acid. Right? It is kind of funny. It's like, you've got to be kidding. Really? On top of the other stuff? Sorry, I didn't make this stuff up. Some molecules can rearrange themselves. So water can act as an acid or a base. We learned that before. Let's look at water being a Lewis base. Well, it's got these lone pairs of electrons. It's kind of a hallmark of what a Lewis base looks like. Here we have carbon dioxide. Well, how does carbon dioxide act as a Lewis acid? It's got a complete octet on its carbon. But what can happen is we can take the pair of electrons that was making the double bond and make that a lone pair on this oxygen. This oxygen now still has an octet, but this oxygen the carbon now is deficient, right? And so this lone pair from the oxygen can go to be shared with the carbon. And then this lone pair up here gets shared with hydrogen, and you have this happening, carbonic acid. So students are always asking me, was OChem harder or easier? OChem is different. This is like a preview of organic chemistry, and I don't want to scare you, but just, they'll teach you how to think about it like this, but there's a lot of drawing curved arrows and moving electrons around. Because carbonic acid, technically is an organic compound. So these electrons can go over there, those go up there, and then those go over here, and these go down there. Carbonic acid. Some cations can act as Lewis acid. These are those small, highly charged metal ions we talked about on Monday. They have empty orbitals because they lost some electrons. So here we've got aluminum 3+, and we've got water being the Lewis base. So aluminum and water can form an adduct, where the oxygen of water is donating electrons to the aluminum. And we can make this guy. So the concept of Lewis acids is an important concept. Is it going to be a big deal in this class? No, it's not going to be a big deal.